Welcome to Industry 4.0 TV on this session of Industrial IoT Live Lab, where we explore tools and techniques to help you build the connected factory. So if you're new to this channel, make sure that you subscribe and click on the notification bell to make sure that you don't miss any of the episodes. We do this every week, every Thursday at 6 p.m. Central European Time. So please subscribe and make sure you keep your notifications on so that you can get us whenever we go live. So today I've got the giant of IoT, both literally and figuratively, and we're going to be exploring the MING Stack and do a demo for you all. So Mark, thank you so much for coming through today and sharing your insights with the community. Maybe if you could introduce yourself.
Yeah, thank you for inviting me. Actually, it's a first introduction, but yeah, maybe because we met, no? You say this, but yeah, usually people don't introduce me like this. So my name is Mark Pose. I'm developer advocate at Balena. I'm also running IoT communities such as IoT Barcelona community and IoT Stars. And yeah, I'm actually enjoying a lot the journey of trying to bring or trying to bring tools to accelerate the way developers get introduced into the industrial IoT.
Awesome. So I see Anthony, thank you so much for joining us, and Dilip, thank you so much for joining us. So if any of you have got questions throughout the session, please feel free to drop them on the chat, and then we're going to answer all your questions as we go along. So Mark, over to you. Shall we get started?
Yeah, I will do a tiny presentation, but I want to do like a very hands-on workshop. If anyone has an Intel device, I'm not sure this is I haven't tested on a Raspberry Pi or similar, but if anyone has an Intel device available that we can just delete everything on the disk and flash a new operating system, yeah, join us on this journey. I have a couple of machines here on my table, so I will try to do some magic and show what's the MING stack. But before, just let me do a tiny presentation. Let me share my screen. Okay. All right. So, okay, this is like the first question I love to ask everyone when I start these presentations of the MING stack. How did you learn programming? How did you learn programming, Kutsai?
Yeah, I mean, I started really. So I actually have a background in embedded systems programming. So I was really starting to work with assembly language, very low code programming,
Oh, wow.
right? Yeah. So that was my entry into programming.
Fantastic. And in the chat, I don't see this question was not for Kutsai, actually. It was for everyone in the chat, please. So let us know how did you learn programming, please. Let's see what people say. Dilip, Anthony, and they are the only one who says hello. Okay, this is how I learned programming. I started learning programming with this computer I had at home, and I started learning BASIC and DOS. So, and it was interesting to get to learn programming with this, but it was complicated and hard. And something that actually, before I got into the university, I got into web programming. And something that it was super interesting is to use frameworks or different tools together that accelerated how I could learn specific technologies. So this is why I like to explain how. So when did you start programming something? Did you use any framework or did you use any stack to reduce the friction? Oh, thank you.
Nalala? Yes, Nhlanhla. So that's Nhlanhla Ncube. So he says self-taught through experience and at university. Do you have reference to any tools that you used, Nhlanhla, throughout your programming journey?
Yes, exactly. So did anyone use any framework or any stack to reduce the friction on getting introduced or getting superpowers on that programming? Actually, yeah, let me, just to accelerate and have enough time for the demo. At university, I started with Java, no framework. Well, Java, it's a kind of, they have multiple frameworks, actually. But yeah, at the beginning of Java, it was a bit of freedom, I can imagine. Actually, as I was saying, when I get into web development, I got superpowers because I started using this stack. It was called LAMP, LAMP. Okay, L stands for Linux, Apache, MySQL, and PHP. This was coined in 1998, actually, and this actually is the origin of a lot of developers before the boom of the dot-coms. Most of these developers learn LAMP as programming, and instead of making everything from scratch, like making a web server or making a database or etc., they just started with these, and on the top of this, they could start making web applications. Okay, so yeah, we have as well basically C and Visual Basic Studio. So Visual Basic Studio basically, was one framework or one system to accelerate or to give superpowers to developers, right? So basically, with the LAMP stack, it helped a lot of people to accelerate. And actually, with a developer from the community from Balena, where I work, we were asking ourselves why LAMP succeeded at that time. So basically, it reduced friction to developers. It was open source and free. All of these 4 technologies were open source and free. It was flexible and scalable, and there was a big community that support the LAMP stack, and you could ask everyone to help, etc. So can we do something for the Internet of Things and the edge computing, or can we do something for industrial IoT for developers who don't have a lot of knowledge on IoT or on industrial IoT, but they want to do some applications on the top of some Modbus sensors, OPC UA, etc., etc. Or again, as I was before, I knew LAMP stack. You just need to reinvent the wheel and do everything from scratch. And this is basically where I started working with this developer from the community, who was Alex Lennon. So how can we move this LAMP-like stack to the IoT and industrial IoT? And actually, after talking with him and seeing some of the examples, I realized that a lot of people was using this not only for industrial IoT, but as well for other use cases. Okay, I'm not going to get into that. I gave a lot of presentations about this, but I'm going to focus on industrial IoT. Okay, because on IoT, we have a lot of devices that are very cheap and with elements or open source technologies like the LAMP stack can help us to reduce the friction on building things. And this is how we start calling this the MING Stack. Okay, what is the MING Stack? Basically, MING Stack stands for MQTT, InfluxDB. Well, MQTT is for data communication. If you don't know, MQTT is a PubSub protocol, publish subscribe protocol. InfluxDB is the database. It's basically a time series database. Node-RED is for the N. It's basically, as you're going to see in some seconds, a UI for data processing and data acquisition and data transformation. And finally, we have the G for Grafana, which is, as you're going to see, a data visualization tool to build dashboards in a really easy way. So basically, we have these 4 open source technologies that have, as LAMP stack, has like a wide adoption. You can have a lot of support from these different tools, and they're available to start working with them. And actually, I know a lot of people using that on industrial IoT, in the industrial IoT stack, basically mostly in the edge, but I now see more and more people using it as well in the cloud. What we are going to do today, we are going to show you how to deploy the MING stack on an Intel NAC or an x86 device. This is why I said at the beginning, if you have an x86 device, a PC with you that you can just completely flash with a new operating system, I'm going to show how to do this almost from zero. Okay, and we are going to deploy Node-RED, HiveMQ as an MQTT broker, InfluxDB as a time series database, and Grafana to build some dashboards. And all of this is going to run under Balena. Okay, I'm going to explain in a second what is balena, but everything that I'm going to explain here will be compatible with any Linux operating system running Docker containers. Okay. On below that, we are going to have some Modbus device and OPC UA sensors sending data to Node-RED. Okay, and we are going to see what we are going to do in a second. What else? Okay, how to get started. So as I said, we can do it in two ways. So we can reinvent the wheel and do everything from scratch, or we can basically, what I like to say, deploy with balena. Okay. Basically, what we can do is to have a Linux device, a Linux operating system machine, and just install MQTT, HiveMQ, InfluxDB, Node-RED, and Grafana on the top of the operating system and just connect all of them. Or basically, what I'm going to try to do is just to give some extra superpowers, which is that we are going to run balena. And basically, balena, what it does, it's an operating system, open source based on Linux, that it only runs containers, Docker containers. Okay, so as I said before, everything that I'm going to show you here, it's going to be compatible with any Linux and Docker containers. And why we use Docker containers on the IoT with balena? Basically, it's because of, I was talking about web development some minutes ago. And basically, at the origin of balena, the founders, they 10 years ago or 11 years ago, actually, they were a bit envious or jealous about web developers. They were saying, why it's so hard to update an IoT device, and it's getting super simple to update a website, right? If there is a typo on a website, how long it takes to update a website? No, the Industry 4.0 TV website could say it's nothing, right?
Yeah.
Just access there or deploy a new version and it works, right? And 5 minutes later, this is fixed. But if you have a gateway on a factory, how long it takes to update the software running on that factory?
Well, you have literally have to. Yeah, well, in most cases, you literally have to drive out there, right, and update the software. So it's a long time.
So as we were 11 years ago very jealous about web development, we tried to introduce some of the most used tools or robust tools that DevOps and web developers were using at that moment, and we brought them into the IoT and edge computing. And this is what I'm going to show. I'm going to show how to run Docker containers on IoT devices and basically run this MING Stack to just don't start from scratch your IoT project or your industrial IoT project, but start from like having a protocol to publish and subscribe data, data storage, data processing, and data transformation, and finally data visualization. Okay. In case that you don't know what is balena, maybe you have used this. I don't know if you never used this, could say. Anyone in the chat used this?
Let us know in the chat if you've
I don't know. If, probably no one is watching us. I don't know.
Yeah, we've got some people online who are watching.
So basically, this is Balena Etcher, and this is a product made by Balena. Basically, Balena Etcher, it's a tool to flash SD cards or USB sticks and flash operating system there. So if you have a PC and you want to install a Linux operating system on that PC, okay, multiple times, no, okay. So if you need to flash an operating system to a machine, so we have this tool to basically select the operating system image that you want to flash, the target, and then just click flash, and it works. Okay.
Yeah,
fantastic.
I see we've got
look at this.
A lot of people have used it, and we've got some who have not used it. So quite an interesting mix of both.
Yes. The important part is that, balena, so this project, we did this project open source for everyone available because we thought that this could reduce the friction to people to flash USB sticks or SD cards. But it is just one product that we have at Balena. Balena basically have multiple products. As I mentioned before, we have Balena OS, which is the open source Linux operating system. Basically, it's an operating system based on Yocto, and it only runs containers. Okay. why do we have an operating system for IoT, a Linux operating system for IoT, instead of using another one? Because we try to support as many devices as possible. So Balena OS is support on more than 100 different device types. So that means that you can have a fleet of IoT devices with multiple devices, and all of them running Balena OS and being managed by the same software. Okay. When I say that that we only run containers, we just use Docker Moby project, and we just forked that project, and we created this project called Balena Engine here on the top. This is our Docker engine, and it's basically an engine for containers that, it's very solid for IoT and works really well. And then on the top of that, we have, so why do we do this? Okay, let me maybe explain why we do this. We do this basically to allow anyone who needs to update the software running on their IoT devices to give these superpowers to the developers. So you need to update your gateway because you have a new HiveMQ version for that customer. Then with Balena, you can just update the software running on your IoT devices in a really simple way. Okay, and we do use containers because it's really simple actually to update containers running on Balena. To manage all your devices and the software updates and everything, we have two possibilities. One, which is Balena Cloud, which is our premium tool. Balena OS and Balena Engine are open source. But Balena Cloud, it's not open source, but you can connect up to 10 devices for free without introducing any credit card or anything. Or instead, if you want to run full stack open source, you can use OpenBalena. Okay, so you have a full open source stack that allows you to update the software running on your industrial IoT devices, basically gateways, as you're going to see. Two more products that we have, Etcher, and we have Fin here on this slide. This is outdated. Now we have Balena Hub that I'm going to show you in a second. Balena Hub, it's a marketplace for IoT applications. And you're going to see that basically everything that we are going to show you in some seconds, it's on Balena Hub in the marketplace. Okay. Some more details of Balena operating system and Balena engine. Basically, we have the operating system running on your device, whatever it is. And then we have a supervisor, which is an agent that it's running on Balena devices, that it's connected to Balena Cloud or OpenBalena, and with the operating system. And it basically asks, is there any new version for me, for my software? Yes, if there is a new one, just the supervisor is in charge to update the software running on the device. Actually, today I was speaking with Kutsai, and we had to actually flash a previous release, right? So we were on the release 113, on one of your devices, and we just moved to the release 110, so 3 releases before. So actually, the supervisor as well is in charge of that. So we just said from Balena Cloud, hey, I moved this device from release 113 to 110, and it worked really well. And then it's as well in charge to manage all the containers next to it. So in this case, we're going to have these 4 containers. We're going to have HiveMQ, InfluxDB, Node-RED, and Grafana. And basically, you can run more containers next to it. Okay, I think we have a question. So we can use this for over-the-air updates? Yes. So this is what we do at Balena. So we do over-the-air updates for Balena devices only, not for other types of devices. So Balena OS only works on devices that has 1 GB of RAM and 4 GB of disk. Okay, it's a Linux operating system. So it does not run on microcontrollers. Okay, for microcontrollers, there are other tools that do exactly the same. But for gateways that you have on factories or etc., so you can run Balena OS perfectly. So we are going to show these actually. We can run more containers. So for example, in this screenshot, this is Balena Hub that I'm going to get here in a second. But actually, in this screenshot, we are running Grafana, InfluxDB, the MQTT, Node-RED, and another container, which is called Wi-Fi Connect. Wi-Fi Connect, we are not going to run Wi-Fi Connect today, but this is a really interesting service because if your device doesn't detect the Wi-Fi from your lab, for example, basically converts your device in a hotspot. So from your mobile phone, as you do maybe on a hotel to connect to the Wi-Fi of the hotel, you just connect to your device to the Wi-Fi Connect service automatically, because it appears as a Wi-Fi on your mobile phone or your computer, and just introduce the credentials from the Wi-Fi from the new location, and reprograms the Wi-Fi credentials. So I think we are ready, right? Let's build it together. Kutsai, are you ready?
Yep, absolutely.
Okay.
Yeah, so maybe while Mark is still kind of like walking us through that, can you please let us know if you've worked with any of the 4 technologies, MQTT, InfluxDB, Node-RED, or Grafana? Let us know in the chat. Just give us the name of the technology that you've worked with so we can get a sense of that.
Just a last detail. So what we are going to do now, it's already deployed. So I have an Intel NAC device, an x86 device, a PC, running on Balena OS, as I'm going to show you, and it has Node-RED, HiveMQ, InfluxDB, and Grafana. So we are going to have some PLCs or Modbus sensors sending data over Modbus and over OPC UA. On Node-RED, we are going to convert that data, and we are going to actually modelize this data. Well, we are going to get this data. We're going to send it to MQTT, and then we are going to store it on InfluxDB and on Grafana. And basically, we are going to, if we have time, I hope so, we are going to iterate this. This works well if you have one location, right? But when you have multiple locations, what do you do, right, with the MING Stack? So we just made this available as well for multiple locations. And what we do is this. I imagine that, Kutsai is in Munich, in Germany. I'm in Barcelona, in Spain. And we are the managers of industrial, factory plants. Actually, running the same stack will automatically make this work. The only thing that we need is an MQTT Cloud Broker. In this case, we are going to use the HiveMQ Cloud Broker. And with the HiveMQ bridge extensions in the edge, automatically all the data from Node-RED that is going to be sent to be published via MQTT to the local broker, it's going to be automatically published into the HiveMQ Cloud, as you're going to see in a second. Okay, so what we are going to do as an iteration of the MING Stack to actually scale these is we are going to model the data following the ISA 95 for the data from the sensors, and basically with the bridge extension send publish these topics to the HiveMQ Cloud. And from there, we can use DataCake or anything just to subscribe or any other service and just visualize this data. Okay, yes, so let's just start. Now I'm ready to show. Okay, if anyone wants to start from home, basically, as I mentioned before, best place to start is Balena Hub. Okay, you can go to the apps and write MING Stack. And basically, we're going to start with this MING HiveMQ application here. I have multiple applications, as you see, but we're going to start with this. Okay. And basically, if you click deploy, what it's going to happen, it's going to go to Balena Cloud. If you don't have an account, you will sign up. And automatically, what it's going to say is, hey, you are going to deploy this application, which is open source. It's on my GitHub repository. Maybe I don't know if you can copy and put it on the chat, Kutsai, please.
Yeah.
And basically, what it's going to do, it's going to deploy this application. What it's going to deploy. So in case that people knows or don't know Docker, as I mentioned before, Balena only works on Docker. So if you know Docker or you don't know, so there is Docker Compose, which is a tool for multiple containers. And basically, it's like a cooking recipe, right? So we are going to say to a machine, hey, we want to deploy these services on this machine. Basically, we want to deploy HiveMQ4. We want to deploy InfluxDB from this image. This is a pretty old image, but I'm using this one just to reduce friction because this is compatible with ARM with most of the ARM devices that I have at home. So this is why I'm using instead of the latest that it's commented, I use the 1.7. We're going to deploy Node-RED and Grafana. Okay, so this is like the cooking recipe, the Docker recipe for. I don't know if you have questions, just interrupt me. Feel free.
Sure.
Okay, so alternatively, you can click this big blue button, deploy with Balena, and it will be exactly the same as clicking deploy from Balena Hub. Okay, and once you will be there, so for example, I created this MING Industry 4.0 application for generic x86 devices. Next thing that you will need to do is click Add Device. Then select, for example, development, introduce your Wi-Fi credentials here, and then click Flash with Balena Etcher. And then actually, you will need to follow this instruction. Basically, you flash a USB stick like this, and then you just put the USB stick, get into the BIOS of the PC, and basically say, I want to start from the USB stick. The operating system will be flashed on the device. Then you just restart the PC, and the PC will appear here. Okay, I have two devices here running. Actually, both are in my home at Barcelona. And we are going to start playing with the Intel NAC. Okay, we have questions, right? How did you try to deploy Kubernetes? Okay, so we don't use. So Balena doesn't run Kubernetes. Okay, it's basically the goal of Balena is to run in the edge. So every device needs to be self-sustainable, running the container. So we don't run any Kubernetes. Having said that, there are some developers from the community, which, if I'm not wrong, made this Balena Rancher application available. So feel free to research on these and see how. But we don't. At the moment at Balena, we don't. Balena is not compatible with Kubernetes made from Balena itself. Okay. Would like to see how Balena OS compares with Portainer Business Edition. Okay, this is that's okay. This is a very good question. Actually, I love Portainer, and actually I made Portainer running on. If I'm not wrong, it's here. Portainer, no, it's a blog. I think I made a blog of Portainer, if I'm not wrong, some time ago. I love Portainer, actually. So this is I made this. So you can deploy Portainer on Balena. Okay, what is Portainer? From my point of view, Portainer it's a tool to manage Docker containers on your edge devices, and actually you can do more. You can actually deploy with Kubernetes, etc. But the part missing for me from Portainer, it's the part below the Docker management layer. So this is what we do at Balena. We do all the part below. So we do all the operating system, following the latest kernels and everything. So we made multiple devices compatible with this operating system. Something that I explained. So you can update the software running on the IoT devices, but as well you can update the operating system running on the devices. Now today I was speaking on support with a customer who needed to update the software running, the operating system on a device that they had running, I don't know where, that it was like 5-year-old, and the device was still running. And I was helping them to update the operating system to the latest operating system version. So this is not something possible with Portainer. I understand that they work on the top of the operating system and the Docker. So this is what the main difference about Balena and Portainer. Having said that, you can run Portainer on the top of Balena if you want. I think it's very interesting what they do. But basically you can see Balena Cloud kind of similar as Portainer. Yes. Also, you can manage container remotely, and you can access remotely what configuration we and applications running as a container. Yes, I'm going to show you this in a second. Maybe Portainer give more freedom on. This is something that we are building right now at Balena. So actually, this is because, as I was explaining at the beginning, we wanted to bring all this web development, all this philosophy from continuous integration and continuous deployment from web developers and DevOps into the IoT. Okay, so I remember on Portainer, I could basically, I don't know exactly what term they used. I could just introduce a new Docker container meanwhile the device was running. So if you want to add a new container on Balena right now, it's still not a bit. So you can still don't do it as Portainer. You have to do a new push, so new release, and the new release brings a new container. But you cannot do on hot, like adding new containers.
Yep, I think there's no more questions.
I think I reply everything more or less.
Yep.
Okay, so let's. I don't know if anyone is sleeping, but basically, I have this device, and I'm gonna get into the local IP address, okay, of my device on the port 80. Basically, I have Node-RED. Okay, yeah, so I have it open here. Okay, so I have a Modbus device attached to my computer. So the first thing I'm gonna do, I'm gonna call this flow Modbus to MQTT. Fingers crossed that the demo gods are with us, because we are going to do everything from scratch. So basically, I'm going to do a Modbus read. And this is an XY MB02, like the cheapest Modbus sensor I found on Amazon, thanks to Kutsai's recommendation. And then we're going to read two addresses, and the poll rate at the one will be 2 seconds. Okay, and we are going to read, I also tested this some minutes ago. So we are going to read from /deb/tty USB 0 from my device. Actually, it's Modbus serial. It's not even Modbus TCP. Okay, and this should work. Let's test this for a second. Okay, let's deploy. Okay, connected, and let's see if we see some data here. I don't know why we don't see any data. Let me refresh this. Second,
do we need to do an inject there? No?
Wait a second. Okay, no, yeah. This is a, sorry, it's a read input register. So we are going to read, yeah, sorry. I always forget. I don't know why there is no, like, introduce. So, okay, we do, so the address is the 4, and yeah, we are going to read the registers. It's nice that sometimes, yeah, there is this triangle here that tells you, okay, so this is what it says. Basically, the register 0 is the temperature, the register 1 is the humidity. So I'm sweating a lot right now. Okay, so what we are going to do here, it's basically, yeah, this is not, so the temperature is in Celsius degrees, so it's 29.1. So we need a function to convert this. And then what we are going to do is we are going to send this data on MQTT. Okay, we have an MQTT broker, and the HiveMQ that I showed you before. Where we have the MQTT. Okay, I'm going to use this. Use an MQTT out here. Okay, so yeah, it's on localhost on port 1883. And we're going to say this is plant 1. Okay, and then the function, basically the function that I want to do, it's this.
Okay, so basically now we're making the connection between Node-RED and MQTT, right?
Exactly. And yeah, if I don't do anything, what we can do now, for example, it's okay. Yeah, let me do this. So what I'm going to do here, so we are, on the one hand, we are publishing, and on the other hand, I created another flow that where I want to get subscribed to any topic being published to this broker. Okay, and then I'm going to store this on InfluxDB. Okay, so basically what we are doing, this is not going to work. Okay, But just to explain what I like to do for a second, let's call it this MQTT to InfluxDB. What I like to do, basically, it's to say, okay, I like to decouple things. This is why as well, no, into the containers philosophy, right? So we decouple projects and things with the operating system. So we have Modbus serial, and we send it over MQTT. And we have another flow that basically it subscribes to MQTT and basically gets any data on it from MQTT to InfluxDB. Okay, instead of just coupling Modbus with InfluxDB, I just decouple these because in case that we want to change InfluxDB for something else, instead of going to a lot of places that, as we're going to have in a second, we just might change this node, and the data will be stored in MongoDB or Postgres SQL or Redis or whatever we want. Okay. On the other hand, I have an OPC UA device here, so I'm going to do exactly the same. So we are going to actually get all the data from OPC UA and send it to the MQTT broker. So basically, for just to tell to the OPC client that needs to read, we need to inject some timestamp. We're going to say that the endpoint, what do I have the endpoint? What we are doing, okay, this is, I have a simulation server made by Proxy's OPC UA simulation server. Okay, and what I'm saying is that you need to run on this OPC TCP address, and then from the injection of the timestamp, we are going to mention how many how many seconds needs to run, needs to read. So, and then as before, so we are going to publish this on MQTT. We have the localhost, and this will be the plant to imagine. Okay. Instead of this, we're going to do a debug here. And let's go to the timestamp. We're going to say that we want to read every 2 seconds. And the topic that we are going to use is on, I have proxies on another computer next to me. And it's telling me that the topic needs to be this. 1003. Okay, so we are saying, okay, from OPC UA, read every 2 seconds from this topic on that URL. Okay, and just publish this data to the topic plan 2 on MQTT. And here we are saying, hey, every 2 seconds, get the Modbus data. We have a function here that we're going to use in a second, and just publish it to the plan 1 topic on MQTT. And here we have an MQTT broker that reads from everything, and basically we are going to print everything. So let's try to deploy this, and if it works, we're going to get, yes. So we get from plan 2 this random number, and from plant 1, so these different topics, the temperature and the humidity. Okay, yes. So yes, so how you configure, this is a very good idea, and this is a very good question. So what's my recommendation on the MING Stack, Ravil? My recommendation is, 1, MING Stack should work for prototyping industrial IoT applications. So as you see, we are here prototyping with a Modbus sensor and an OPC UA sensor in a really easy way. Okay, if you have 1,000 tags, you can do something. You can replicate this 1,000 times, or actually you can replicate this container 1,000 times, and basically changing the configuration. So there are different ways to do it. Okay, but yeah, then on the top of the MING stack, there are other tools that help you to accelerate this. So for example, if you want to run these 50,000 tags, there is other software like Neuron, for example, N3 Neuron, which makes, if you go to the Balena blog, basically I have here an industrial IoT project, which is basically very similar of what I'm explaining. It's a MING stack with Neuron instead of Node-RED. And what it does, they have templates, and that accelerates getting thousands of Modbus different sensors, etc., instead of doing by hand this. But if you want to just prototype and test things, etc., the MING stack, it's the way to go instead of trying to learn how the templates work and how all these, like a more complex tool works. On the other hand, Neuron, it's not free. So it's free during 2 hours. So yeah, it's not open source. So this is why I think just to get introduced into the IoT and industrial IoT projects, something like the MING stack, it's very useful just to understand what happens, show some data, and just understand if there is a return of investment for your company or for your customer, digitalizing their factory and their legacy devices. No, what do you think, Kutsai? Do you have other recommendations?
Yeah, absolutely. Yeah, I mean, once you start to get to the scale of 50,000 techs, then you need to kind of like start looking at an industrial grade tool, right? That has got all the tooling that you need to handle like 50,000 techs. So as Mark pointed out, the MING stack is mostly suitable for like small IoT deployments where you've got maybe under 100 techs or so. And then you know that you could run that reliable, because also with 50,000 techs now you need like a commercial solution really to guarantee you the kind of uptime that you need there.
Yeah, indeed.
Yeah.
So yeah, the recommendation is, yeah, if you're going to connect 50,000 or 500,000 tags, probably you have a good return of investment, right? And the company is, no, if you have 50,000 Modbus sensors, that means, yeah, there is some money related on that. So it's interesting maybe to use like a commercial tool on that. That's a good point. So something that, yeah, this is not working yet, but something that I want to do here is to start modeling the data before I store it on InfluxDB. So what do you think? Should we modelize this using ISA 95, Kutsai?
Yes, so yeah, I think we could use ISA 95 object modeling there, but also kind of like really mention that as far as this is concerned, ISA 95 really is just kind of like a recommended, because it's a standard that already exists, but it's not a hard rule that you need to really use ISA 95. You can create a custom model that makes sense for your solution or for your company. But if you need somewhere to start, just kind of like any standard to use, ISA 95 would be a good place to start.
Okay, so what we are going to do, so we are going to introduce the temperature and humidity. Yeah, it's still not normalized, the temperature and humidity as you see on the logs. So we are going to divide it by 10. And on the other hand, we are going to call it, so motor temperature and motor humidity. Okay, on the one hand, and this belongs to the compressor one. So we have the function one, and then here we are going to connect, instead of before sending it to the plan two, we're going to add a function just to send this data. Let me think what I did. Yes, here. Yeah, I have this function somewhere else. I'm copying and pasting. So we're going to do something like this. And this function do something like this. It's very simple. So we get the message payload, as you see, is raw here. So we get the motion. This is actually random data, but this belongs to the compressor 2 from plant 2. And we're going to put it here on this ISA 95 model, object model. So we store this. And now if I deploy it, okay, and before that, yes. So we want to store it. So to store it, actually InfluxDB, this version, the 1.7, doesn't understand the ISA 95. So we need actually to parse the data and to store it as on the payload that InfluxDB understands. So we are gonna add a function here that actually will get the data from MQTT, and it's gonna do something very simple. It's gonna check if the message payload has compressor 1 or compressor 2. Then you can, if you have 50 compressors, you will need to have a switch or something like that. Okay, and then basically we are gonna get, if the parameter is compressor motor temperature, we'll store the data following this. If it's compressor motor humidity, something else, and if it's motor motion, this. We are gonna use the measurement, which is kind of the table. So if you compare, how InfluxDB 1.7 use the measurement concept, it's like on SQL databases, the concept of a table. Okay, so in the table or in the measurement compressor, we are gonna store the field's motion, humidity, and temperature with associated timestamp. Remember that InfluxDB is a time series database, so it needs to have timestamp associated with it. Okay, and then we are gonna send this. I actually created something crazy, but which is, I like to store the raw data. So lately, I'm meeting a lot of people who is asking me about the data lakes on industrial IoT, enterprise data lakes versus data warehouses, blah, blah, blah. And it's interesting. So data lakes basically stores the data as is. And data warehouse, basically what it does, it models the data into a specific data object or data model. So it's easier later to query this data. If you use the data lake so you don't model the data before you store it, then before visualizing or building an application on top of this data, you will need to model the data later with ETLs or something like that. Okay. I'm not going to cover that, but I'm going to show that, you can have a function where you just store the raw data, which is ISA95. So in this case, we model the data on ISA95. So we're going to have a measurement called raw data that we are going to store the ISA95. In case that on the top of that, or we, for example, want to query historical data, and instead of having the temperature and humidity numbers, we just want to have the ISA95 data because there is an application that reads that type of data modeling. Okay, and we are going to do this as well. And I'm going to click deploy. Let's see if I killed anything or everything. It's okay. Yeah, something else. So, okay, I created the InfluxDB. Basically, I say that it's on localhost and the database balena. So basically, let's check if this exists. So usually, if it's not created automatically, I get into the CLI or InfluxDB. So yeah, I didn't get into the Balena Cloud. Basically, on Balena Cloud, we have the logs of the services running here, the services, IP addresses. But we have a terminal where we can SSH to each of these services. Okay, in this case, I SSH into the InfluxDB service. And now I think I can do show databases, if I'm not wrong, or show, so I have the database balena already created. So what I'm saying here is, okay, so store the data on the balena database. And basically we see here, so for example, that we are storing motion, and we are storing temperature and humidity. Okay, looks like it's working. Okay, so last step, actually, it's getting into Grafana and starting visualizing things.
So maybe before we jump into Grafana, I think there's a question from Ziad that we can perhaps address.
Can I use a loop for sending? Sure, yes. So what do you mean, Ziad? I understand that you have 500 different addresses in Modbus or OPC UA. and you are reading at the same time, yeah, why not? Yes, you can do a function or something like that reads, no? Or what do you think, Utsai?
Yeah, maybe Ziad, if you could clarify your question, but I guess maybe what it's asking is, can you do it simultaneously? Can you do a loop that collects and sends 500 texts at the same time? So yeah, maybe if we could clarify the question there, Ziad.
Yeah.
But it should be possible.
Yeah, have in mind, yeah, that the scalability of Node-RED is not, yeah, it's limited. I mean, it scales pretty well. But yeah, you need to think that at some point you will need to start queuing, not using queues to send the data in batches. So yeah, just find what is the right ratio of number of tags that you can send at the same time through MQTT, but that should work. In this case, yeah, we're sending a simple. This is a simple example, but I have seen these running with a lot of different tags at the same time. Yeah, so this is Node-RED. Sorry, this is Grafana. Sorry. Yeah, I didn't. The login and password didn't appear, but it's admin. For Node-RED, actually, it's balena. And basically, what we are gonna do is we are gonna create a dashboard from here. But before that, you need to add a data source. So what we are gonna say is that our data source is InfluxDB. Okay, and we are gonna, yeah, the URL it's HTTP localhost, and the port it's 8086. Okay, so a big disclaimer here: we are not using security or passwords or anything here, or authentications. So yeah, if you are going to run this as a proof of concept on your laptop, that's okay. If you want to deploy this on a place where you need extra security, just please don't use, so start using certificates or TLS or more security. Okay, and if you remember, yeah, the database is balena. Okay, we save and test. Okay, and it says that 2 measurements are found. And now we go to dashboards, create your first dashboard, add visualization. Now we have 2 of these. And I don't understand this. So I go actually to full SQL query. So we have, if I'm not wrong, temperature from the compressor. If I'm not wrong. And if I do this, and I call it temperature, let's see if this works. Maybe, yeah, I think I did wrong the data source. I'm using the wrong data source. Yes, this one. If I'm correct, no, we are sending the data. Sorry, here. So what we are saying, it's a compressor measurement called compressor. Okay, yeah, it looks like we have some data here. Let's see, let's get some fingers crossed that it's gonna work. I'm gonna duplicate these and I'm gonna get the humidity. Yes, sorry, this is it. Yes, yeah. Pressure, and then actually we can get the motion, if I'm not wrong. I don't know why we don't see any data. I want this to be refresh every 10 seconds. Okay, so we have data here at some point, but we don't get any data. Let's see why not. Okay, now we have data. I don't know. Yeah, there was an error there. Okay, so I want to see the last 5 minutes. Okay, we're going to see if my air conditioner works well or not. What else? Okay, so now I have one device, right? And as I promised you on a chart here, how can we actually make this work in parallel in multiple locations? So for that, we need like a central place that gets all the data and unifies all the data coming from different places, right? So this is what I'm going to show you how to do it in just 1 second, because it's super simple. HiveMQ brings a special feature called bridge extension that makes this super simple to send data on a specific HiveMQ cloud solution, or maybe your on-premise HiveMQ broker. And basically, actually, I think we are already using this. Yeah, we didn't mention this. So yeah, so our device is running some variables. Okay, I mentioned, for example, that the username and password of Node-RED is balena. This is because it's defined here. So if you override this and put your username and password, it will be completely different when you sign in for on Node-RED. And then we have multiple variables here that are related to HiveMQ. There is one which is called HiveMQ bridge extension, which basically, as default, it's on false. But actually, yeah, before connecting here, just for testing purposes, I move it to true. Okay, and basically what we are doing now is we are sending the data that it's being published on the local MQTT broker. It's being sent with this bridge extension to an MQTT broker in the cloud, which is basically on this host URL on this port with this username and this password as security. And basically the TLS is enabled. So it's going through a encrypted channel, okay, to this. Actually, we are not using the topics configuration. Maybe this is for another video if you want to learn more about the unified namespace and how to run the topics configuration on HiveMQ. But basically, with this configuration, actually the data that we see here, it's being sent to the HiveMQ cloud. And just to demonstrate that, if I'm not wrong, I have the MQTT Explorer here, as mentioned before. So we have MQTT protocol. This is the host URL, the port, the username, password, and basically I have to check on encryption TLS. And if I connect, so we start to see data from, you remember we have 2 topics, the plant 1 that is sending data from compressor 1, and the plant 2, which is sending data from compressor 2. And basically, yeah, you see that, for example, for plant 2, it's sending every 2 seconds, I guess. We define on Node-RED. So we see here that it is being sent to the cloud connection, and we see here the temperature, which is not changing a lot. Yeah, it's changing a bit, yes. And we see here the data. Actually, we can add, I want to see the motion in a second. Duplicate, and I want to call it this one. Edit, I want to call it motion. Sorry for, I think I call it motion. No?
Yeah, just quickly to say, just apologies to our viewers here. We're going to go over the time here, but this will all be available on YouTube. So if you've got to run, that's okay. You can always come back. You'll find the video recording on YouTube. But if you have got some time to stay on, that would be really great while we still finish up the solution here.
Exactly. Yeah. Sorry for taking too long, but yeah. So we have in real time, we are visualizing the data, and on the top of this, how long it took to reach this, like 30 minutes, 1 hour maybe. In 1 hour, we had all of these on Node-RED up and running. So in a really, really easy way, you can have like Modbus devices, OPC UA devices, sending data through an open source stack, and basically starting from the MING Stack. You don't start from scratch. You don't need to deal with how Modbus works, how can I not read OPC UA data, etc., etc. You start from something that allows you to start building innovation on top of this, and taking and making sense on the top of this. What do you think, Utsai? Is this enough?
Absolutely.
Or?
Yeah, I think we actually might have just made it on time. So maybe just quickly, I think Ravil has got a question in this regard. It is interesting. Does Node-RED read one tag value data time by calling read request or creates OPC1 subscription? So Ravil, there's some Node-RED packages. I know Klaus Lansdorf has got a package that allows you to kind of like browse through an address space and like get the object. So if you have got an object that has got multiple variables within it, you're able to read all of that at once and then manipulate it once it's within Node-RED. So this is just one example of using OPC UA read on Node-RED, but there's other OPC UA packages that allow you to do that multiple subscription of multiple tags.
Indeed, yeah. So yeah, when you log in as with balena or with the username and password that you define on Balena Cloud, basically we have already installed these all the nodes that you saw on the left, Modbus, OPC UA, InfluxDB are already installed, but you can install other modules here. For example, if you need any specific OPC UA, so we have these installed, but you can use others. Or the good thing of Node-RED is that you can build your own module on Node-RED and just use it. So this is like, this is super interesting.
Yeah, absolutely.
Rabil is asking, can Node-RED use subscriptions? What do you mean by
yes, again, that is specific to the OPC UA package. So there, I think you've got to subscribe there.
I think so. So I haven't tried it, but yeah, if your OPC UA device allows you to get subscribed, I'm sure that on the OPC UA client you can use subscribe. You can use all of these actions actually.
Yeah.
But yeah, I'm not sure if this is the question, if I answered properly the question or not. In this case, yeah, we wanted to read, and we are just polling every 2 seconds to the OPC UA. What else? More questions. Absolutely. People has questions or not?
Yeah, if we've got questions, I think we've got a few more minutes to spare while we wind down. So basically, we've in under an hour created a complete IoT solution with the data collection, data storage, data transportation, and data visualization. So you could like pretty much really deploy this on any factory or any area where you really want to collect data and monitor it. And on top of that, you can push that data to the cloud if you need to collect all of this data from multiple sites into one central location where you can then visualize it, maybe using an IoT platform. Or if you still want to stick to kind of like industrial grade, you can still use a SCADA system that is capable of subscribing to that enterprise MQTT broker and visualize all of that information. So I think if you've got something to add, Mark, but I think if there's no more other questions, this is where we're going to end it.
Basically, yeah, these are my credentials in case anyone wants to contact with me, or you can contact me over LinkedIn if you had any questions. And yeah, I remember, I don't know, it was some episodes ago from Walker Reynolds that he said that he was investing like more than half of his time on the MING Stack, for example, just to prototype solutions for customers and just to implement ideas. So I don't know if Walker is watching this or not, but I'm sure that if this can be like the right stack that you can use to apply innovation on the top. So don't start from scratch. This is my recommendation. Always try to use open source technologies that don't lock in you on specific technologies, and then I think from that you can apply all of your innovation and ideas to make your industrial projects.
Oh, yeah, absolutely. Yep. So with that, I think we'll bring this to an end. So thank you so much for attending this session. So again, we do this every week, Thursday, 6 p.m. Central European Time. So please subscribe to the channel and stay tuned for more content around industrial IoT. So again, Mark, thank you so much. It's been a great pleasure having you, and thank you so much for sharing your insights with the community. Really appreciate it.
Thank you, Kutsai. Thank you for inviting me. See you next
Thank you.
time.
Bye.
Bye.